In this video, we're going to look at solving systems of nonlinear equations. So we can solve nonlinear systems using the same methods of substitution and elimination. We can also sometimes solve them by graphing, and we'll look at this first one by graphing. It's already done for us, graphed for us. So if you wanted to solve this question here, you could graph this and set both equations equal to y. So this would be 2y is equal to x squared, or y is equal to 1/2 x squared. And then the next equation would be y is equal to x plus 4 when I add x to both sides. And you can see these graphs over here. And just like our systems of linear equations, the solutions occur where they intersect. So here we're just looking at, and here the x-axis is down here. It's kind of hard to see in this picture. So that would be -2 and then 1, 2, 3, it looks like. And then another solution, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, at 4, 8. So depending on the system and the type of system it is, there could be more than one solution. There could be no solutions as well. And it's still possible for there to be an infinite number of solutions. However, if we're talking about like a line and a parabola, or a quadratic function and a cubic function, or a circle and a line, then those aren't the same types of functions. So in those instances, there will not be like an infinite number of solutions. So it's a little less, that answer is a little less common. Okay, let's look at example 2. There are, like we said, you can use substitution or elimination. I prefer to use substitution most of the time. So let's look at this one using substitution and just look at where you can get y by itself quickly. So here, this top equation, if I subtract x squared from both sides, then I get y is equal to -x squared plus 9. And then x squared is equal to y. So I can substitute those out, or everywhere I see y in the next equation, I write, -x squared plus 9 is equal to y. -x squared plus 9. And then you'll have an equation that you can solve. It might be one that you can solve quickly. It may be one that you need to use the quadratic formula for, but you should be able to solve it because there's only one equation now in one variable. So here, let's distribute. We'll try to go through this quickly. We have x plus x squared minus 9 plus 3 is equal to 0. And so this gives you, let's just rearrange it in combined like terms. So write the x squared first, plus x, and then minus 6. And this does factor. We can take the shortcut because the number in front of x squared is 1. And two numbers that multiply to -6 and add to 1 are +3 and -2. And so x is equal to -3 and x is equal to 2 after we set both of those equal to 0 and solve. Okay, so just to kind of keep work straight, let's just start our ordered pair. And then we can fill in the y value. And you can get the y value from either one of these equations. If the squared and the negative kind of scare you away, you can use the line. Or if you like the fact that y is already by itself, you can use this equation you solve for. I'm going to do that. I think it's good practice to squaring negatives because that's a common mistake. So if y is equal to -3 squared plus 9, then this is +9, but then it's negative. So it's actually -9 in the end. plus 9. So this gives you y is equal to 0. So that 0 will go here. And then plug in 2. When you square the 2, you're not squaring the negative. So it's positive 4, but the negative in front gives you negative 4 plus 9. And that gives you 5. And so you have two solutions here. Both of these, if you plug them into both equations, they should make the system true. Okay, this one looks like it might be set up nicely for elimination. The thing that's challenging with elimination is you have to be careful that you don't add terms that have different exponents. But because the fact that these y squared terms I can just multiply by -1 and cancel one of them out, or they'll add to 0, it makes me think that that might be a good idea. So let's multiply the top equation by -1 since there's less there. So that's -x squared plus y squared is equal to 1. And I am a strong believer that you should rewrite everything when you do elimination, because I see a lot of people make mistakes. And I'm going to switch the order there. And because when they don't rewrite, and if you rewrite, you'll make fewer mistakes. So then we'll add these together and we get x squared. These add to 0 and it's equal to 4 plus x. And then we're going to move everything. It's x squared, so we need to move everything to one side. So let's move everything to the left. So this is x squared minus x minus 4 is equal to 0. And you should try to factor, but this one does not factor, so this does not come out nice and pretty, which just means it's going to be a little messier with some of the work, but that is okay. So we'll do the quadratic formula. So x is equal to -b, so that's +1, plus or minus the square root of b squared. Let's go ahead and square it and make it +1, minus 4 times a, and then times c is -4, all over 2a, which is just 2. When you do the quadratic formula, do this in one step, not two. Get that number all at once. If you put it in your calculator, that's great, or do it in your head all at once, but really watch your number sign. That's where mistakes come up with the quadratic formula the most often. You get 17 over there, and then 2 on bottom. Now this does not simplify, but you do have two answers here. Let's see, the way we'll probably do this is let's just see what happens if I try to plug this in. Actually, let's do this. Let's estimate a decimal instead of trying to use that exact value. Let's say that x is equal to 1 plus the square root of 17. Whoops. Over 2, and then it's 1 minus the square root of 17 over 2. And so this gives us 1 plus the square root of 17. This is about 2.56. And then here, if we subtract and then divide, it's about -1.56. And then to find y, we need to plug back into one of these equations. Let's use this top equation. And just to make things a little bit easier, let's get the y squared by itself. So let's make it y squared. Do it in 2 steps. Let's subtract the x squared over and then divide by -1. So when you plug these decimals in, you'll just plug them in here and then have to take the square root each time. So it's 2.56 squared and minus 1, which gives you y is plus or minus the square root of that. Let's do 2.56 squared. .36 is what we'll round it to. So we have 2.56 and plus or minus 2.36, and we'll talk about that in a minute. And when I plug in the negative 1.56, that would be y squared is equal to negative 1.56 squared. And because you're squaring the negative, just ignore the negative sign. Don't. I wouldn't even type it in your calculator. And then you have to find that value and then take the square root. So 1.56 squared, and then minus 1 in the square root of that is about 1.19. Actually, it's 1.20. So that's negative 1.56 and 1 plus or minus 1.20. So what's happening here? Why are there so many answers? We have 2 answers here and then 2 answers over here. So if we go back to the graph, these are 2 different circles. So if x and y are both squared, those are circles. So somehow these graphs, the circles, well, I'm not going to even draw the coordinate plane because I'm not going to think about where they hit. But I have a circle that, and these circles are intersecting in a couple different spots. Likely it's something. Oh man, those are bad circles. So they're hitting in a couple of different places. Okay. Oh, actually, those aren't circles. What am I thinking? Those are hyperbolas. And so we have this graph with a couple of different pieces. And let's see, it would take a little bit more work to figure out exactly what's going on. But there's a couple of different pieces that are hitting in different spots. So it could look something like this. And we'll talk about those graphs probably. If you haven't learned about hyperbolas yet, you'll probably hit them after this in your course. Okay, here we have another example where there's a couple nonlinear things. X is already by itself, and so we could plug that in for this X up here and see what happens. The other option would be to we could get y squared by itself and plug it in on the other one. Let's kind of do both real quick. So if I plug X in x equals y squared into that top equation, then that gives me y squared squared. And it's not that that's a bad thing necessarily. We can deal with that. But the y to the 4th is something that we don't always love seeing. But you can keep going with that, or you could say, well, what if I substituted the other way? But that could just be factored, and it wouldn't be too bad. So you could say, well, I know y squared is equal to x. So if y squared is x, then I can substitute there. And this might give you something that is a little bit like you're used to seeing. So we have x squared plus x is equal to 4x. And maybe this isn't quite as intimidating for you with the exponents. Either way, it works out about the same. This is quadratic, so we set it equal to 0 by subtracting 4x from both sides. And I can factor out an x. And then when I set both of these equal to 0, x is equal to 0 and x is equal to 3. And you can see this from this graph we've given here. So there's our our spots. And then I would start your parentheses. And then from here, just plug in x is here. So we have y squared, or actually I'll do 0 is equal to y squared from the bottom equation. So that's just 0. You can see that from the graph too. Or 3 is equal to y squared from the bottom equation, and that's plus or minus the square root of 3. And you can see those points there. And I think it's okay to write this here. If you want to write it as, because there's 3 solutions, and so if you want to write it as 0, 0, 3, negative square root of 3, and 3, positive square root of 3, that's okay too. So either one of those is fine. Okay, and this says find all solutions, and this is rounded to 1 decimal place. So here we have a circle up top and a quadratic on bottom. This is one where you could solve. Well, I guess in your graphing calculator it'd be tough, but you could solve in your graphing calculator. However, it would be some tricky manipulation there. So let's go ahead and solve with substitution. Because there doesn't seem to be a good way to use elimination. But y is already by itself, so I can write this as x squared, and then instead of y squared, we have 2x squared minus 5x, and that is all squared, is equal to 12. And this looks kind of messy, but we can FOIL this. And then when we multiply these out, we get x squared, and then plus 4x to the 4th, and then minus 10x squared minus 10x squared gives you minus 20x squared, and then plus 25x, or wait, this would be x cubed in the middle, 25x squared. And then let's move the 12 over to make it minus 12. And then here, let's combine like terms. So we get 4x to the 4th minus 20x cubed plus 26x squared minus 12. And this is one that we either need to solve like with our polynomials, or we can factor it, hopefully. So if we can factor by grouping, which it's not going to factor by grouping. So actually, we're going to scratch this one. I would say use graphing. Actually, it said like use graphing calculator. Or Desmos. I'm sorry about that. So this is kind of this dead end here of solving, but yeah, we'll skip that. So what you could do is you could graph this using the graphing calculator, but how do you deal with that? So if you get y by itself, you get y squared is equal to negative x squared plus 12. And then when you take the square root, it would be y is equal to plus, so this, you could enter this in y1, plus the square root of negative x squared plus 12. And then y2 would be minus the square root of negative x squared plus 12. And that would graph your circle in your calculator. And then in y3, is equal to 2x squared minus 5x. Now, unfortunately, I don't have a graphing calculator I can show this to you, but when you type all those in your calculator, if you hit second and then calc, there's an intersect command you can do to find the intersections, find where the graphs intersect. Okay, and let's look at these two word problems. This is a circular piece of sheet of metal, has a diameter of 20 inches, and the edges are to be cut off to form a rectangle area of 60 inches squared. So and then what are the dimensions of the rectangle? So if you're looking for variables, like think about what you're looking for. So we need a length and a width. So that's probably our variable. Let's call this length and this width. Diameter is 20 inches. Now this is where this problem is tricky, I think, is because when most people will think about diameter and think about like up or down, but that doesn't give us any information. So there's always a different diameter. You can draw a diameter anywhere on the circle, and the one that's the most useful in this case is here, because that gives us a right triangle. And I know this is 20 inches. And so if you remember the Pythagorean theorem, a squared plus b squared equals c squared, and you know the area of a rectangle is length times width, then you have your two equations. So we have w squared plus b squared is equal to 20 squared. Whoops, let's do length and width, like mixing my variables. And then we know our area is 160. So we know 160 is equal to length times width. And then we can solve this using substitution. Let's see, what would be the quickest way? Maybe you could use substitution by getting w by itself on the bottom here, and we'll change this to 400 in a minute. So if I solve by or divide by w, then length is equal to 160 over w. Okay, so that means this guy and this guy are the same. So let's write 160 squared over w squared plus w squared is equal to 400. Okay, and then we have this equation where w squared's on bottom, so we have to get rid of that. So let's multiply both sides by w squared. And that will give me, numbers are getting big here. It's 160 squared, the w squareds cancel, plus w to the fourth is equal to 400 w squared. Okay, and then this is a quadratic, so we can get equation set equal to 0, and then let's see if this factors. When this factors, we have w squared and w squared, and it's equal to 0. And then we need to find two numbers that multiply to 25,600 and add to negative 400. Okay, and those two numbers are 320 and 80. So it'd be minus 320 and minus 80. And if you need to, I would like graph this and look for solutions that way too. You don't necessarily have to factor this. So like here, I would maybe like graph and find the zeros. Because w is equal to, or w squared is equal to 320 W squared is equal to 80. So the width has a lot of different options. It could be, and actually it's not too many different options. I know we'll talk about that in a minute. But it's plus or minus the square root of 320, or plus or minus the square root of 80. So what's happening here? Well, we don't really care about the plus or minus because we don't want the negative width. So the square root of 320, actually we'll just leave it as a square root of 320. If that were the width, then the length would be the square root of 80. And if square root of 80 were the width, then the length would be square root of 320. So the width would be 320. And you can do this, square root of 320, you can do this by dividing 160 divided by the square root of 320. If you want, you can plug it back in. But the length would be the square root of 80. Excuse me. Okay, so this next one, a hill is inclined, so the slope is 1/2. And then there's this system here. This rocket's fired up, and it gives you an equation. And they want to know, at what point does the rocket strike the hillside, and how far is the point from the base of the hill? Okay, so at what point does it hit the hillside? Well, we have this equation given to us for the parabola. And then this tells us a slope of 1/2. And so that's just the equation y is equal to 1/2 x. So we have y is equal to 1/2 x, and y is equal to negative x squared plus 401x. And so you can set these equal to each other because they're both equal to y. You could also graph this and solve this graphically. We'll do this algebraically, even though I would probably do it graphically. This would be 1/2 x is equal to negative x squared plus 401x. And then we can subtract, actually, let's move everything to the right to make that x squared positive. So it's x squared plus 1/2 x, and then minus 401. Oh, that's 401x. So let's put that together. So it would be minus 400.5 x. And then this one's not bad to solve. We can use a greatest common factor. And so x is equal to 0, which is when it takes off. And then x is equal to 400.5. So that is this value here. (400.5). And so then to find the point up, we can just plug it in to y is equal to 1/2 x. And so that is 200.25 is how high it is. And they also want to know how far is it from the base of the hill. And so that would be from, if you were to go on the incline. So that would be if you wanted to, so here's the point, I guess let's write that. Use the Pythagorean theorem on the next part. And then using the Pythagorean theorem, you can do a squared plus b squared equals c squared to find this distance here. So 400.5 squared plus 200.25 squared, and then take the square root of that, and that's something you can type in your calculator all at once. to get a distance of 440. Well, you do 448. Okay, there's your 3 distances. Please reach out if you have any questions.